In this video, we're going to take a look at adding and subtracting rational expressions. Now, as we keep talking about in this unit, rational expressions is just a fancy way of saying we're talking about basically pretty ugly fractions. Fractions with a lot of variables in them and algebraic variable expressions. So here, as we've done with all the other stuff, what we want to do is we want to model what we do with just what we've done normally with regular fractions. So for example, like this problem, you want to ask yourself, how do you add and subtract fractions normally? Well, if you recall from the past, it's all about having a common denominator, like this problem here, 7/5 minus 3/5. We're talking about things that are measured in fifths. So in this case, since they're the same denominator, what we can do is just basically look at the numerators. 7 of these minus 3 of these is 4, and the unit of measure we're looking at is fifths, so we end up with 4/5. So our only job today is to basically take this just one step further with rational expressions, like this problem. In this case, I've got 2 over 3x plus 1 and plus x plus 4 over 3x plus 1. Now here, just like in our problem, the denominators are the same. So in this case, all we have to do is say to ourselves, okay, I've got 2 plus x plus 4, in which case we just pay attention to the like terms. X is by itself, but then 2 plus 4 are like terms. We have 6. And then over our common denominator of 3x plus 1. Now, the question comes up though, what do you do when the denominators are not the same? Like this problem right here. 5/6 plus 1/10. Well, in this case what we do is we look to see how we can create a common denominator. And normally we would do this in our heads and look for a least common denominator between 6 and 10, but I think because our problems are going to get more complicated, we want to kind of break it down in terms of what we do in our thinking. Well, typically what we usually do is we think to ourselves, all right, well 6 is made up of 2 times 3, and then 1/10 is basically 2 times 5. And so what we start thinking about is, okay, how are these the same and how are these different? Well, in this particular instance here, the factor of 2 is the same. So they are common in the sense that they both have a factor of 2. But this one has a 3 that this one does not. So what we learned in the past to do is to multiply top and bottom by 3. And it's still the same fraction because 3 divided by 3 is 1, and timesing by 1 doesn't change anything. Now, they both have a factor of 2, they both have a factor of 3. Now in this fraction, what we're missing is that factor of 5. So here we multiply top and bottom by 5, and we eventually get an answer, which would be in this case a common denominator of 2 times 5 times 3, which is 30. And I'm running out of space here, so on your paper you can just go ahead and put it next to it, but I'm going to put it over here, which would be here, common denominator of 30, and a common denominator of 30 here. And on top we just clean it up, 25, and here 3, and now we can add these up. 25 plus 3 is 28 over 30. In which case we would reduce this answer, which reduces down to 14/15. And again, try to do this a little neater for your notes. Okay, so take that same thinking and just apply it to rational expressions. Here's a rational expression where the denominators do not match. They kind of match a little bit with the x's, but for the most part they don't. Well, again, think of it in terms of factors. What factors make up these denominators? Well, 6x squared, if we break it down, is 2 times 3 times x times x. Everything underneath 5. And then over here, we've got 3 over 5 times x. So we look at this in terms of what's the same and what's different. In this case, what's the same about these is they both have an x, but that's pretty much it. So we think to ourselves, what do I need to do to make everything match? Well, this denominator over here needs a factor of 2 to match up here. Needs a factor of 3, and needs a factor of x. Now everything here matches with what's over here, but this one is missing a factor of 5 that this one has. So there we go. Okay, our denominators now match. 2 times 3 times 5 is 30 x squared. And then same thing for this one. All this multiplied together is 30x squared. We now have a common denominator. Now on top, 5 times 5 is 25. Over here, 3 times 2 times 3 is 18x. And now I put together my numerators. 25 plus 18x over 30x squared. And if there were anything to simplify, I'd go ahead and simplify this like the last problem, but in this case there isn't, so that would be my answer. Alright, let's try another one like that. How about this problem? There we go. Simplify 7 over 8 n to the third plus 5 over 12 n squared. So, once again, let's take a look at what matches and what doesn't. 7 over 8 would be 2 times 2 times 2, and n to the third, plus, over here, 5 over 2 times 2 times 3 is 12, n squared would be n times n. Alright, so what matches, what doesn't? Let me change my pen color so I can see what I'm adding to this problem. In this case, 2 of the 2's match up, but there's a third n here which I need to make match over here, so I'm going to multiply top and bottom by 2. This one has a 3 that this one doesn't have, so I'm going to multiply top and bottom by 3. And then here I've got n, n, and n, 3 of them. Here I've only got 2 of them, so I need an additional n over here. So now, putting all this back together, my common denominator is 2 times 2 times 2, which is 8, times 3, which is 24. N times n times n is n to the third. Under, I should say, 21. Over here, this should be the same. 2 times 2 times 3 times 2 is 24. N times n times n is n to the third. Now I have my common denominator. 5 times 2 times n is, oops, ignore that. This pen skipped. Should be 10n. Okay, add up the numerators. 21 plus 10n over 24n to the third. And once again, I look to see if I can simplify it, and in this case we can't, so that would be my answer. Okay, so it's basically taking our understanding of adding regular fractions and moving on to rational expressions. Now let's try 2 more. These are a little more complicated because of the denominators. If you take a look here, in this case, again, what we want to look at is common factors. Now, first we have to factor it, but in the case of a binomial like this one, the way we want to factor it, like we've been learning in this chapter, is, in this case, 2x plus 4. I can simplify that into 2 times x plus 2. I'm going to use distributive property to break it up into factors. Minus 4 over x minus 1 cannot be factored further, and so the most we can do there is put it in parentheses and make it into its own factor. So now there's our different factors, and again, it's all about making the denominators match up. So for example, here in this second denominator, we don't have a 2 that this one does have, so I'm going to multiply top and bottom by 2. It also has an x plus 2 that this one doesn't, so over here I'm going to multiply top and bottom by x plus 2. Now, this one is missing what this one has, which is an x minus 1. So I'm going to multiply top and bottom by x minus 1. Now, like we've been doing with some of the problems we've been working on, it is okay to leave the denominator in factored form. In this case, I'd even encourage it because maybe there's something that's going to cancel later. So I'm just going to use our common denominator the way it is. 2 times x plus 4, or sorry, 2 times x plus 2 times x minus 1. And even though it's out of order, it's the same denominator over here. 2 times x plus 2, x minus 1. Now, the numerators, though, I can't leave it in factored form because I have to do the subtraction. I have to clean all this up. So here, distributive property, we get 3x minus 3 minus, now over here, 4 times 2 is 8. So I'll basically just go ahead and distribute the 8, which would be 8x plus 16. And now I can add up the numerators. Be careful with the subtraction problems. We got to remember that everything over here is getting subtracted from this. So 3x minus 8x would be negative 5x. Negative 3 minus 16 is negative 19 over our common denominator. And once again, I looked to see if I could simplify this further, but negative 5x minus 19 cannot be factored further, so it's not going to cancel with anything down here, so I'm just going to leave my answer in factored form. Alright, let's try one final problem. Let's try this one. As far as our work goes, this will probably be as hard as it gets. In this case, what we first want to do once again is look at what factors make up these denominators. So in this case, 1 over y squared minus 9, I'm hoping you guys see that's one of our difference of square shortcuts. This would factor into y minus 3 times y plus 3. Plus, now this one we're going to factor using FOIL or generic rectangle or whatever method you like. In this case, this would turn into y plus 2 times y plus 3. Alright, once again, now that we can see the individual factors, let's make them match up. Now, in this case, they already do match up a little bit. This one has a y plus 3, as does this one. So those I don't need to worry about. But here, I've got a y minus 3 that this one does not have. So I'm going to multiply top and bottom by that factor. Over here, this one is missing a y plus 2. So multiply top and bottom by y plus 2. And now our denominators match. Y minus 3, y minus 3. Y plus 3, y plus 3, y plus 2, y plus 2. Alright, and once again, in case I need to reduce later, I'm going to leave this denominator in factored form. Y minus 3, y plus 3, y plus 2, plus, and then over here the same denominator. I'm going to put it in the same order as the first one so I can see that they match. And now we clean up the numerators. Over here, 1 times this is just y plus 2. Over here, same thing, just times 1 is y, in this case, minus 3. And then we go ahead and add our numerators. So this plus this would be 2y minus 1. And then once again, we check to see if we can simplify like we've learned in previous lessons. In this case, 2y minus 1 cannot be factored, and it doesn't match with anything here. So in factored form, here's our answer. Alright, so there's a little bit on adding and subtracting rational expressions. And to me, once again, the idea is not so much anything new here. It's just this concept of taking what we already know how to do from a year or two back about adding and subtracting fractions and applying those same steps to rational expressions.